So let's work through a numerical example. The first thing that we want to do is to think about what our box looks like based on our initial endowments. So the initial endowment is just how much X and Y each consumer starts with. So here we have Anne and Ben. And Anne starts with 6 units of X and 2 units of Y. Ben starts with 2 units of X and 4 units of Y. That tells me that total X is equal to 6 plus 2, or 8, and total Y is equal to 2 plus 4, or 6. So as a small society, we have 8 units of X and 6 units of Y, and we want to represent that in our box. To draw the box then, we'll draw the y-axis a little bit shorter than the x-axis. Remember, we're going to put person A on one axis and person B on the other. So for Anna, her y-axis is going to range from 0 to 6 along this side of the box, whereas Ben has 0 to 6 for good Y along this side of the box. I'll also make some lines within the box just to help us get our bearings. So again, for Anna, this axis goes 1, 2, 3, 4, 5, 6 up, and Ben's goes down. We'll do the same thing for good X. For Anna, good X can range from 0 to 8, and likewise for Ben, from 0 to 8. And every point within the box represents a different division of these 8 units of X between Anna and Ben. Each could have 4, or some other division that's less equal. Once we've constructed the box, we need to find the initial endowment point. So here, Anna has 6 units of X and 2 units of Y, which of course corresponds to Ben's 4 units of Y and 2 units of X. So that you can see each point in the box represents a different allocation of our 8 units of X and 6 units of Y between Anna and Ben. This is the point we start out with, but of course it might not be the point we end up at. That depends on how much Anna and Ben like X and Y and if they're willing to trade with each other. To see that, we can plot their indifference curves through the initial endowment. For Anna, I know that her initial utility is 12, so the equation for her indifference curve will be 12 equals XA times YA. All bundles that multiply to give Anna a utility of 12 will be along her indifference curve. So we could think of points like 3, 4, 4, 3, and 2, 6 as also being along her indifference curve. For Anna, 3, 4, 4, 3, and 2, 6 give me a sense of what her indifference curve looks like. I will highlight it just to add some color to the graph to make it easier to see. For Ben, his utility function is a bit more complicated, but we can do the same thing. Ben's original utility will be 2 squared times 4, which is 16. So the equation for his indifference curve would be 16 equals xb squared yb. So yb would equal 16 over xb squared. seems useful to think about points within the box where we can plug xb into this equation. So for example, if xb is equal to 1, yb would be 16, which is not within the box, so it would be difficult to plot. But if xb equals 2, yb equals 4, that's our initial endowment point. Let's try xb equals 3. If xb equals 3, yb would be 16 over 9, which is 1.7. If xb equals 4, then yb would be 1. So 4, 1, and 3, 1.7 are also points along Ben's indifference curve. We'll use a different color to highlight. Again, just to make the graph a little easier to look at. So, is our initial endowment here socially optimal? No. No, it's not. There are potential Pareto improvements that fall within the area between the two indifference curves, and we could shade that area here to show us all the points that Anna and Ben would prefer to the initial endowment.